Hello everyone, myself Ranjita Yadav, Senior Assistant Professor in ABS Engineering College, and I will explain you the topic of 8259 Programmable Interrupt Controller. And I will explain you what is the use and what is the application of 8259 Priority Interrupt Controller. We know that in 8086 there are two interrupts, maskable interrupt and non-maskable interrupt. Maskable interrupt is INTR and non-maskable interrupt is NMI. So, what is the basic use of priority interrupt controller is it accept interrupt requests from peripheral devices, resolve their priorities and issue an interrupt to the INTR input of the 8085, and that one is the INTR input. Next one, this IC is manufactured by NMOS technology and 8259 add 8 vectored interrupt to the microprocessor, and this controller can be expanded without additional hardware to accept up to 64 interrupt request inputs. This expansion required a master 8259 and 8 8259 slaves. That one is the IC diagram of 8259. And these are the interrupt requests. That one is the IR0 to IR7, which handle up to 64 level of interrupts. And that one is the most important, that I will explain you the architecture of 8259. That one is that blocks, that one is used for, these signals are used to interface to the 8086 microprocessor. That INT input connected with INTR input of 8085 or 8086, and that one is the acknowledge of INTR input. That one is the INTA bar. That data bus buffer is used. That data bus buffer is used to interface internal data bus of 8259 with the data of 8085 or 8086. Basically, these signals are used to interface with 8085 or 8086, and that read-write logic, read signal connected with read signal of 8085 and write signal connected with write signal of 8085 or 8086. A0 signal, that one is the address line connected with address line of 8085 or 8086, and remaining address lines are decoded with chip select for decoding logic. Next one, that one is the most important part of 8259. These are the 4 blocks, and that subsystems handles all the external interrupt request. First one is interrupt request register. This blocks stores the actual interrupt request from external interrupt device. It is a 8-bit register having 8 flip-flop D0 to D7 correspond to each IR levels, IR0 to IR7. It stores the status of various interrupt devices connected to IR levels. Next one, that one is in service register. That one is, this blocks identify all the current interrupts that are serviced by the microprocessor. The ISR acts as a buffer between the interrupt request register and the 8086. That one is also 8-bit register having 8 flip-flops correspond to each IR levels, and it stores the information regarding the IR levels to which microprocessor currently servicing. Next one, that one is priority resolver. This block determines the priority of the bits set in the IAR. The highest priority is selected and stored into the corresponding bit of the ISR during INTA pulse, and that resolve the priorities of various IR levels as programmed by the operation command word second. That one is the interrupt mask register. That one is also 8-bit register having 8 flip-flop correspond to each IR level, and it can be programmed by an operation command 1 to store a particular bit which enables or disables the corresponding IR levels. So as to enable and disable the particular IR level, the programmer has to transfer logic 0 and logic 1 in corresponding bit of interrupt mask register. And that one is the next part, cascade buffer and comparator. This section generates the control signal which are necessary for cascade operation. It also generates enable signal for tri-state buffer in case of buffered system. The 8259 PIC can be cascaded in order to extend the interrupt handling capacity up to 64. In such a case, the former is called as master and later are called as slaves. For master PIC, cascade cascade lines CAS0 to CAS2 are output, and for slave PIC they are as inputs. In respect to first pulse of INTA bar pin, master PIC puts output 3 bits identification number on cascade lines to select one out of 8 possible slaves PIC. Each slaves compare this code with the code assigned to them during initialization. The slave PIC output interrupt type microprocessor on receipt of second pulse of INTA bar pin. Next one is SP bar oblique EN bar. That signal. This bidirectional paper form two functions. One, in non-buffered system acting as an input, it is used to specify that whether 8259 PIC has to act as a master or slave. For 8259 PIC to function as master, so SP bar oblique EN bar pin is kept as plus 5 volt and 0 volt respectively for slave operation. Next one, that one is the cascade operation of microprocessor, in which these are that one is the master 8259 which will be connected with microprocessor. That one is any 8085 or 8086, and INT pin of 8259 connected with INTR pin of 8085 or 8086. These are the IR levels, IR0 to IR7, and each level connected with slaves 8259 PIC, IR0 to IR7, and the INT input of slave connected with IR0, IR1, IR2, IR3 up to IR7. So it will handle up to external interrupting device up to 64 levels. That one is the connection diagram of 8259. Just like that, that one is work as a master and that one is work as a slave. INT pin of slave connected with IR6 and VCC connected with SP bar oblique EN bar, because that one is works as a master and that one is SP oblique EN bar connected with ground, because that one is works as a slave. Next, all data lines are connected with data lines of slave. These are the cascade lines CAS0, CS1, CS2, which will provide identification number to the slave. And INT pin of the master connected with the processor. That one is the process of 8259 PIC. Thank you very much.